Yeah, hi. Michael, this is work from my student Arun, together with Anna and Likwan Gool. So I think I can skip that. So yeah, there's two dominant approaches I see for doing well, video interestingness. One is to use some additional information about the video, like the title is often used. So you can basically localize the part that actually shows something that relates to the title, and a lot of people have used that. And the other way is just using supervised learning with generic features, which I guess a lot of people did here, and we did too. And then there's some works that combine this. So one thing we did is we tried to use the title to figure out what's the most interesting part of the video. And we did this through a textual-visual embedding. So basically the idea is you project the text, which in this case is the video title, and the frames into the same space where you can measure similarities between text and image. And then basically to find the most interesting or the most relevant frames, you can just compute cosine similarity between the title and the frame, and all the frames in the video. This is based on a paper of Liu in CVPR 15. And we did some improvements on this, where we, for example, used an LSTM to encode the text, because the text is multiple words, and what we need in the end is a fixed length representation. And we used VGG19, which we fine-tuned. We did this on another data set, on the ClickShare data set, which is a click data set of image search. The second is we had a model at CVPR this year, which is called Video2GIF, where the goal is to rank segments of a video according to the suitability as GIFs. So basically we extract segments and then we learn a ranking of these segments. And for this we used C3D, which is a 3D convolutional network, so it is in space and in time. And we trained it with a ranking objective, so the goal is to score positive segments higher than negatives. And for this we also have a large-scale data set we collected, which is about 100,000 GIF image pairs, GIF video pairs. So basically the way it works is that you have a video and then we know which part of the video was selected as a GIF. So we assume this is the interesting part, and we use that for training. Here are our results. So we basically took this textual-visual embedding trained on another dataset and directly applied it on this task, which is run 1. And then we also fine-tuned it for this task, which is run 2. And we tried training it on a bigger dataset, which didn't improve for some reason. What's important here is, I guess, we don't really learn an interestingness model, but we learn a relevance model between the video title and the frames of a video. So I guess what we didn't do, but what would obviously help, is to try to combine that with a model that directly predicts interestingness from frame level. And then for the video run, we took Video2GIF, also pre-trained on this other dataset without any fine-tuning. And we tried combining Video2GIF with the textual-visual embedding model, which led to some improvement. Yeah, there's some results. We can see that when we use the title, it really depends on how descriptive the title is, right? So sometimes the title has a clear visual meaning, and then usually our method works pretty well in actually finding frames that match to this visual meaning or to the title. But sometimes the title is not very informative in telling us what frames we should select. Here's some, if you want to know more information, we had this Video2GIF paper at CVPR. I also have a slide from a longer talk. And actually we have a demo where you can try the Video2GIF, and you can just paste the YouTube URL and it will create GIFs from it according to what parts of the video it thinks are the most exciting. And the last paper is basically what was our baseline method for the textual-visual embedding. That's it.
Thank you.